Welcome to qnawire.
Okay, we are being asked to find the intervals on which f is increasing and decreasing, the local max and min, and its concavity and inflection point for f of x. Before we proceed, there is a small error here. This is not supposed to be x. This is just x to the fourth times e to the minus x. I apologize for that. So we'll go right into it. So where are we going to find increasing or decreasing? We first have to apply the first derivative test, which means taking the first derivative. So since this is the product, we're going to apply the product rule. So this is going to give us 4x cubed times e to the minus x. Since e to the minus x, there's a negative x here, and we apply chain rule. This will give us negative here. And then it remains the same. E to the negative x. And we can pull out a, apologize for that. And we can pull out a x cubed and an e to the negative x. So then that is a common factor. And this will leave us with 4 minus x. And we set this whole thing equal to 0. And we know that this occurs where x is equal to 0 and 4. So now we are going to create a sign chart to figure out where this is exactly where this is increasing and decreasing. So this is our number line. We're going to put 0 and we're going to put 4. Bring this down, bring this down. I'm going to include x cubed and e to the negative x and 4 minus x all together. And we're going to evaluate the signs. So for numbers less than 0, we get negative for x cubed, positive, positive. And e to the negative x will be always positive because that's an exponential function. And then for 4 minus x, there will be positive, positive, and then negative. Now you multiply this to get the sign of f prime. So then we're going to get negative times a positive times a positive is negative, and then positive times positive is negative, and then positive times a negative is negative. So now that we know the sign of f prime, we know what is increasing or decreasing. So it is increasing on between 0 and 4. So between 0 and 4. And it is decreasing from negative infinity to 0 and 4 to positive infinity. And we can also figure out the local mins and max because we know the directions in which the function is moving. Since this is decreasing and then increasing, we have a local min at x equals 0. And then it is increasing and then decreasing. So then we have a local max at x equals 4. Now for concavity, we have to take the second derivative test. So we take the second derivative, and that comes out to be x squared times e to the minus x times x squared minus 8x plus 12. And then you can factor x squared minus 8x plus 12, and it comes out to be x minus 2 and times x minus 6. You set this whole thing equal to 0. And there it is equal to 0 at x equals 0, 2, and 6. This is a 6, by the way, not a 1. So a 6. So then we do the exact same thing. We create a sign chart. So we have a the number line, and then we're going to include 0, 2, and 6. And since x squared times e to the minus x is always positive, we're not going to include it. And then x minus 6. And then these two multiplied gives us the sign of f double prime. So all numbers between less than 0 for x minus 2 gives us negative. Numbers between 0 and 2 give us negative. Between 2 and 6 gives us positive, and this gives us positive. For x minus 6, this gives us negative, 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 positive. Now we multiply, so negative times negative is positive, negative times negative is positive, positive times negative is negative, and positive, and positive times positive is positive. So when f double prime is positive, we know it is concave up, so concave up, which is U sign, and that occurs from negative infinity to 2, and from 6 to infinity, and then concave down, which is upside down U, occurs between 2 and 6. So our inflection points are where the sign changes for concavity. So inflect point occurs at x equals 2 and 6 because it's going from positive to negative and then negative to positive. And that is it.